All right, guys, here we go. Study group for the Unit 8 retest, which we're going to do on Monday. I got about 20 of you guys filled out the form for this. You guys all realize now that is a requirement, and I will be giving or not giving test points for filling out forms. So you got to do it. And so here we go. I'm going to go over the questions that people said they wanted to see. Sometimes I might do them in order of most questions. You can always, if I'm doing a question that you don't want to see, you can always skip it, fast forward to the next one. So I'm going to do the first problem right here. This is on the corrective. So what we're trying to do is the first four non-zero terms of the Taylor series. So it's, like a Taylor polynomial. Now there's really, since it's centered at zero, that's Maclaurin. And that means we can use some of our shortcuts, which you really want to use, because I'm not going to do it, but you can look at my solutions to see the work that would be involved with taking multiple derivatives and plugging the center in, which is something you need to know how to do, but I don't recommend it if you can avoid it. If it's centered at zero, you shouldn't have to do that. So the quick way is to realize that this is the same thing as x times, there's a couple ways we could do it. I think we could just say, okay, let's think of this as a over 1 minus r. And so this is your a value, and this is your r value, positive 2x. So the first term is x, and then we multiply it by 2x, and we get 2x squared, and then we multiply it by 2x, and we get 4x cubed, and we multiply it by 2x, and we get 8x to the fourth, and you're done. Otherwise, you can take lots of derivatives, which I'm sure we'll eventually see one where we have to do it that way. But if it's centered at zero, Maclaurin series, please use memorized series. Like number 2, I'd use the memorized series for e to the x, and then plug in 3x's wherever the x's are in parentheses. These should be fast problems. Now, problem 4 is not centered at zero. So do not try those tricks. You can't just say e to the x and multiply by x, and you can't do that. So this one, we actually do need derivatives. Starting with the 0th derivative, which is the original function. Some of you guys on the original test skipped that, kind of ignored it. And f prime of x is, now this is going to be product rule. So it's going to be x times derivative e to the x is e to the x, plus e to the x times derivative of x is 1. And then the second derivative is going to be the derivative of this, which is another product rule. X times derivative of e to the x is e to the x, plus e to the x times derivative of x is 1, plus the derivative of this e to the x is e to the x. So that simplifies to x e to the x plus 2e to the x. There is a pattern that is emerging that, derivative x e to the x is going to have x e to the x and then another e to the x. But then there's another 2e to the x, and so that's going to be 3e to the x. It depends on how many of these we need. We need the first 4 non-zero terms. So if any of these give us zeros, then we're going to need more terms. So then what you do is you plug the center into this. And this is something that I feel like people were missing. Some people were missing that on the test. So plug 1 in this, it's 1 times e to the 1. So that's e to the 1, or just e. And then the first derivative with 1 plugged in is going to be 1 times e to the 1 plus e to the 1, which is 2e. The second derivative with 1 plugged in is going to be 1e to the 1 plus 2e to the 1, which is 3e. And then the fourth derivative at 1 is going to be 1 times e to the 1 plus 3e to the 1, which is 4e to the 1. So None of them were 0, so I think we're good to go. The Taylor polynomial, the way we write it, is we say, all right, px, p for polynomial. Sometimes we write t for Taylor. And the pattern is, and I'll just write the pattern here once, but it's the 0th derivative at the center, x minus the center to the 0th power over 0 factorial, plus the first derivative at the center, x minus the center to the first power over 1 factorial, plus, and on and on. And a lot of people who are kind of doing pretty good on this on the test were forgetting the minus the center with the x. So our answer is going to be, the 0th derivative is going to be e x minus 1 to the 0th power over 0 factorial. Well, that's 1, and that's 1 also. So the first term is really just e. Plus 2e x minus 1 to the first power over 1 factorial, plus 3e x minus 1 to the second power over 2 factorial, plus 4e x minus 1 to the third power over 3 factorial. So that's how you do it. You cannot use a shortcut on this one. It's not a Maclaurin series, so you can't use memorize Maclaurin series or those methods for it. So, okay. Moving on to the back. No one else had questions about those other problems, but number 6, people had a question about. Now, number 6 is a Maclaurin series. So we want to go ahead and use whatever we know. So we know that like cosine x is, it's like e to the x, but it's the even terms because cosine is the even function. Starting with the first term is 1, and then the next term, it's alternating, so it's minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus. So that's just cosine x. So if we want x times that, then we're going to just multiply that times x, and that'll give us that part. Sine 2x, so sine x on its own is an odd function. It's going to be the odd terms of e to the x. So remember that e to the x is 1 plus x over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial. Pretty simple pattern. Not alternating. These ones are alternating. First odd term is right here. That's an odd term, right? So that's going to be x over 1 factorial minus x cubed over 3 factorial plus x to the 5th over 5 factorial. Now, we want sine 2x. So sine 2x means that we can actually just replace all the x's with parentheses x. Now, you got to put in parentheses because the cubed has to be applied to it. Okay. So we're going to subtract this from this. So if we could go ahead and write out what we have right now. I mean, it's going to be, this has to get distributed, x minus x cubed over 2 plus x to the 5th over 4 factorial. 4 times 3 is 12, times 2 is 24, minus x to the 7th over 6 factorial, which now no calculator on this. I don't know, it might be a big number. Maybe I don't know. I guess we might end up actually needing it. Let's see. Next term here, by the way, would be minus 2x to the 7th over 7 factorial. So what's 6 factorial? Well, it's 6 times 5 times 4 times 3 times 2 times 1. This is 30. That's 120. That's 360. That's 720. So, okay. It's not too bad. Now, the reason I'm doing this is because we're going to be combining a bunch of terms. Like, that's that first part. And then we're subtracting this part right here, 2x over 1 minus 8x cubed over 6 plus 2 to the fifth. So 2/3 is 8, 16, 32 x to the fifth over 5 factorial would be 20, 60, 120. And like we're looking for the first 4 non-zero terms. So the x to the first are going to be there, x cubes, x to the fifth, and x to the seventh. We need that one. So that's going to be 64, 128 x to the seventh over 7 factorial, which would just be another 7 times this. 0, 14, carry the 1 to 40, 49 is 50. I don't know. This is, I mean, I guess we could just say, all right, this is going to be our answer. The first 4, that's going to count as the first non-zero term because together they're going to be, you got to distribute this negative. The first term is going to be negative x. The next term is going to be, we could reduce this to 4/3, but then you're trying to combine it with this, so you probably want to actually keep the 6. So it's going to be positive 8 minus 3 is positive 5x cubed over 6. And then this term right here, we could try and reduce this 60, 16, 8, 30, 4, 15. But then what's the smallest number that 24 and 15 both go into? And I think, unfortunately, it might be 120. So maybe we should keep that there, multiply this by a 5. And so that's going to be negative 32 plus 5 is negative 27 x to the fifth over 120. And that's, we could reduce that, but whatever, that's fine. And then the last term is going to be, and maybe we've learned our lesson, 720 right here goes into 5,047 times. So if we multiply this by 7, then they'll have these common denominators. So it's minus 7, and this is going to be positive 128. So it's going to be plus 121 x to the 7th over 5040. That's the first 4 non-zero terms. I don't know. Maybe I won't give you something so bad, but I guess that's the nicest answer now. The alternative, that was a Maclaurin series. That's us using the shortcuts and stuff. The alternative is, look at my solutions and take all these derivatives to get the same, to get the coefficients. You could do it all together. So I guess that would give us, the nicer answers a little more directly. But I don't know. That's a lot of work. I guarantee you guys are going to start to mess up those derivatives of trig, and there's product rules and subtraction and chain rules, and probably shouldn't do it that way. Number 7. Now, all those were kind of from parts 1 and part 2. Part 1 just had a Maclaurin series on the back, and part 2 had some Maclaurin series, and other non-centered at 0 ones were on part 2. Part 3 had, I think, like these last 3 problems were like part 3. So you guys can retest all the parts or just some of them, but I would just do them in order. If you can do them all, first part should take about 30 minutes. Second part should probably take about max 30 minutes. The third part should take a max of 30 minutes. So maybe a max hour and a half, but I can see people getting all 3 done in maybe even less time. Problem 7, this is the 1, 2, 3, 4th derivative of Taylor polynomial centered at x equals 3. And they're giving you that Taylor polynomial, and they're saying find the 4th derivative. Now, the 4th derivative should be with the term that's to the 4th power. And the mistake some people are going to make is they're going to say, oh, well, the fourth derivative at the center equals 10. No, because remember, this term is going to be, and this is what I would probably do. I'd say, okay, well, the fourth derivative at the center times x minus 3 to the fourth power over 4 factorial, that's the thing people are forgetting, equals that term. So you could then just algebraically solve for this. These would cancel each other out, and then the fourth derivative at 3 is going to be 10 times 4 factorial. And a lot of people were forgetting that on the test. And it's 4 times 3 times 2 times 1, 12, 24, 240 is the fourth derivative at 3. So don't forget that the factorial is part of what's making that number right there. It's part of the coefficient. Okay? So that's the way I would do that. Hopefully that's a quick one. Number 8, similar kind of question. Find the coefficient of this term. The coefficient, that would be the number in front of it. Now that number in front of it involves the sixth derivative at the center, pi over 2, this is x minus the center, over 6 factorial. That's what this whole term would look like if we were trying to create it, and we're trying to find the coefficient. Now the coefficient involves everything that's multiplying the x minus pi over 2 to the 6th power, including the factorial. So now this is referring to problem 5, which was above. That was fx equals cosine 3x centered at pi over 2. So assuming you've already done that work, then we could just use the sixth derivative right away and plug pi over 2. If you hadn't done that work, if this was a standalone problem, then you would want to find the sixth derivative. So the first derivative would be negative 3 sine 3x. The second derivative would be negative 9 cosine 3x. The third derivative would be positive 27 sine 3x. The fourth derivative would be 81 cosine 3x. The fifth derivative would be 243 negative sine 3x. And the sixth derivative would be negative, let's say 729, negative 729 cosine 3x. So what we need to do is we need to plug in pi over 2 into this. So that's going to be negative 729 cosine of 3 pi over 2, because there's a 3x inside here, and you plug in pi over 2 in this. So it's 3 pi over 2 over 6 factorial. Now, I would be fine with you leaving the 6 factorial in your answer. I don't want you to leave cosine 3 pi over 2. You guys should figure that out. Cosine 3 pi over 2. So this is cosine, right? This is 2 pi. That's pi. And right there is 3 pi over 2. And this one's kind of a silly one. It's 0. So the coefficient is 0. But usually you get a number here, and this whole thing would be your coefficient. Okay, so that's how we find the coefficient. You don't need to evaluate all these other derivatives at the center. You just are using them to find that next derivative if you need it. All right, number 9, Lagrange error bound. This is, okay, Lagrange error bound, Taylor polynomial degree 4. This is the function centered at 0 applied to x equals 0.25. So let's set up Lagrange error bound. Lagrange error bound, LEB, equals the absolute value of the n plus 1 derivative at some c value. x minus the center at the n plus 1 power over n plus 1 factorial. Now, degree 4, that's n equals 4. Now, my solutions, I think I'm going to show a little more work right now than I showed originally. All my solutions, I don't know, maybe. That's the center. That's the x value. N plus 1 is going to be 5. So for us, we're looking for the fifth derivative at c. And then 0.25 minus 0 to the fifth power over 5 factorial. So the thing we really need to figure out is that value right there. And this is something that the c value, the c is between the center and the value of x. So that's something good to show in your work. And it's or equals to, so the center is 0, the x value is 0.25. That's good to write down. Now, what you're looking for is the max value of this. So that's EVT. I'm letting us be lazy, but I need some evidence to support it. So some of you guys are getting the right values, but I took off some points because I didn't really see the work. What we do need is the fifth derivative. So this is the 0th derivative, the original function. So the first derivative is negative 3 sine 3x. The second derivative is negative 9 cosine 3x. The third derivative is positive 27 sine 3x. And the fourth derivative is 81 cosine 3x. And finally, the fifth derivative is negative 243 sine 3x. So that's one we're trying to find the absolute maximum absolute value, positive, negative. So what I've been saying is like, okay, well, let's just graph that. It's a negative sine graph, so it's a sine graph upside down. This is usually 2 pi, but it's being divided by 3. So this is usually pi, but it's being divided by 3 because of that 3 coefficient. The amplitude is 243. It might be good to label. And we're interested specifically in 0 to 0.25. Now let's estimate. This is about 1, right? This is about 2. So we're looking at the graph from 0 to 0.25, which I would say is probably right around there. So we're looking at this chunk of the graph. This is me doing EVT really lazy. This is me showing those are the endpoints, and this is the portion I'm looking for. And I'm considering critical points, which it has none, and endpoints. And we're looking for largest value, which is, so I want you to label this. That's our guy right there. So this is what I'm looking for, minimum. I mean, this is the lazy way of doing it. Otherwise, if you want to do the extra work for EVT, show me the table, show me the critical points, show me the endpoints, calculate them all, go for it. But this is the lazy approach, which I'm okay with, but you got to show that. So back up to here, our answer is going to be whatever value that is. So that's going to be, in the absolute value, it's going to be 243. It's negative, but we're going to force it to be positive. 243 sine of 3 times 0.25. So that's 1/4. We could say 3/4 or 0.75. And then it's going to be 1/4 to the fifth power over 5 factorial. So there's your answer. Now, we could, I don't know, try and simplify this some more. But in my work, on my solutions, I'm missing that sine 0.75. Like, I get the right number, but I just didn't write it. So I just want to make sure that wasn't confusing to anyone. But use your calculator to get this, and I'm just going to write out what I get. I get 0.0019775,391, or 1.977539 times 10 to the negative 123. Now the answer I want, this is something else that I wrote down wrong on my answers for the corrective, is we're going to go ahead, just give me 3 significant digits, 3 decimals, and we're just going to round up for sure on that last decimal every time. Don't round down, don't truncate. This is a maximum possible. This is like a worst case error. If we round down and we're saying now the worst case is less than the worst case, that doesn't make sense. So I'm looking for answers of 0.00198 or 1.98 times 10 to the negative third. My answers, I kind of acted like it was okay if you put the 7, but no, we should not round down or truncate. So I'm going to go ahead and stop there and stop this video just so it doesn't get too long. And then, so I'm going to do some questions from the original test next. Okay.